Okay, for people joining this meeting, this is one of our infinite series of incremental language development meetings for Wolfram Language. And we've got a bunch of topics here today that will be for versions after 12.2, because we're wrapping up 12.2 imminently here. So let's get started. WriteLoggingData.
So
yes.
We have Joel.
What's that?
We have Joel to discuss this today.
Right. So, I mean, my basic point is a lot of systems find it useful to have a notion of a log file. We don't really have that. I mean, clearly you could just write something. You could say, presumably, except nobody ever does it. Okay, what will be the most convenient way to do this? Would it be to have some central log file like syslog on an operating system that is a thing at a known place in your file system that is the log file that you choose to write? Would that be a sensible thing for us to have? Comments?
Just one common file for absolutely anything.
Well, isn't that how operating systems usually do it?
There's logs for different services, and then different people have different opinions for different purposes about combining them or whatever. I think that with logging, flexibility is the big thing.
Well, fair enough, but I mean, there's sort of a generic log file, and then maybe, I mean, what does syslog? How does that work? I mean, this is I'm looking at the syslog documentation. Okay, receives and processes log messages. This is on Linux. Well, actually very confusing here. Apple System Log Server. Why is it called Apple System? This is the Linux machine I'm on here. Well, I thought it was. Okay. So this is a centralized server, the syslog daemon, that receives, that is very much like our data drop, except that it's a more lightweight thing that's just going directly to files. Right? I mean, there's an argument. Okay, so let's take a different point of view. Let's take the point of view, what if there was a version of data drop that just did nothing sophisticated, it just wrote data to a file, as opposed to trying to maintain something which is some kind of data, database thing that has sort of, programmatic access, so to speak. What if it was just...
That's like put a pen to a cloud object, is what that sounds like.
Pretty much, yes. But in a standardized way, so that it has, like an Apache log. So it might be in an Apache log format where it's, where we could actually read it in using our Apache log importer, where it has the, the standard timestamp and all that kind of stuff.
Right. So when I think of logging, one of the things I think of is the sort of template, and different systems that I've used in even Apache, there's not one format. There's a template language, basically. Do you want the URL? Do you want the method? So you put little % whatever's in your format statement.
What is that domain specific language there?
It's the Apache log configuration. I'm not sure. I know I've messed with it, but other log systems that I've used are similar. You have opinions about what you want to log, and timestamp is obviously one of them. But it could also be the machine you're on, the process ID, thread ID, all these different things.
Fine. But I mean, what I'm suggesting is a framework for people to routinely do that.
Mm-hmm. And and we really could use something like just a logging functionality. So you're suggesting combining it either with a centralized version or even a cloud-based destination.
Potentially. I mean, maybe I haven't really thought this through, but I mean, maybe that's the default option is, I'm just going to, because, a lot of times, okay, what is the point? What feature? Okay, one feature of log files is most of the time you'll never look at them. Okay. I mean, which is a very different thing from most of the data that we're dealing with. I mean, most data, like with data drop, I think the implicit assumption is you put the data in there, you expect somebody to look at it.
Right.
Whereas with a log file, it's you put it in there, and even if it takes some effort to pull out the thing you want, the point is that it was lightweight to put it in there, and it's in there somewhere. And so, I mean, what you're effectively suggesting is, one could have, for example, one could even have a family of things to write in the logging data, which could be, let's say you had a named collection of things to write, like what is the process ID, what's the machine, what's the time, and so on.
All kinds of environment metadata.
Right, but I mean, but that would be a named thing, and what you'd say is write logging data of quotes, standard log, blump. That's it. That's all you put in your program. And what that would do is it would write it out with some kind of tag, perhaps in the log file. If it's an Apache type log file, maybe we have a code at the beginning of the line or somewhere else or something that says this is a type, AXB line. And so then we could imagine an importer that, in the event that it has to import it, can turn that into a nice clean association, knowing that it's of that format type, for instance. I mean, I don't know what, I mean, obviously things like Splunk specialize in going through log files.
Yeah, I mean, with web logs, there's the whole ecosystem about ingesting these, I mean, that's really what Hadoop is doing, is it's going back through web logs to, calculate traffic and things about your web.
Well, patterns. Right, in our implementation, for example, but I mean, but that's okay. The log file as an HTTP server, is that standardized, or is that also a jungle? I mean, when you say Apache logs, they were invented for the Apache HTTP server, right?
Yes.
That's okay. So is that then standardized, what an HTTP server writes out? I mean, or does Tomcat write different things, and does whatever?
Tomcat has a different, I mean, well, Tomcat, there's Tomcat itself, which does logging right at the beginning, but then every individual application you deploy to a Tomcat server could theoretically do, absolutely different things.
Yeah, I understand, but theoretically, in our language, you can write anything you want into any file you want, right? The goal here is to make a dead simple framework where somebody can just put in a random place in their code, write logging data. Blump, there it is. And, and then we provide some tools to go look at those logs later. And where routinely, I mean, I would do that I do long runs of computations, for example, and I try and log a bunch of stuff for those. But every time I do it, I have to custom write a bunch of stuff that puts this in files, and I have to remember where the files are and this and that and the other. But if I just wanted to know, I come back in the morning and my machine is crashed on the floor, what happened, right? If I had put a write logging data thing in some loop somewhere, I would have known, I just go look at the log file. But 99 times out of 100, I'll never look at the log file because I don't care. Right. Because it just worked fine. So that's what I'm suggesting. So, I mean, my question is, if we had that point of view, that there is a standardized location for a log file, and that most of the time you just put it in there, and that we provide some tools, maybe in the function repository, for reading back from the log file that say things like, just look at the last hour of logs. Something went wrong, just look at the last hour of logs. Or, things that I've done depressingly often, when it's fallen to me to debug some messy thing in our company, it's like you ingest you do something where you're using, various kinds of string manipulation functions to ingest pieces of the log files and so on, and then you're generating, nice simulation, nice things from that. Steve is on a live stream is suggesting that it will be an interesting thing to be able to use things like machine learning to pull out interesting features of logs. I have to say, it's like data scraping. I've done this a bunch of times. I've done this debugging craziness in the cloud. I even wrote a blog post about doing that at one time, where it's a crazy adventure. Like we were trying to find out, maybe you were even involved in that, Joel, where we had
Yep.
these mutex locks, right? And we were trying to find out what created the lock, what destroyed the lock. We were seeing the two ends of the lock, deeply interspersed with all kinds of other crud in the logs. And that was a non-trivial exercise in, scrapery, basically, to pull out what was relevant there. And I have a feeling there probably isn't a global solution, but the thing we're trying to do here is to make it straightforward for people to log what's happening in their Wolfram language sessions, to make it so lightweight that people routinely put the stuff in there, and possibly even that people want to put it in their initialization files so that when they start a session or when an API starts a session, it puts something in the log. I mean, like, for example, when you call an API function, it could be the case that you would really want that to just throw something to the logs.
Yep.
I mean, we are throwing something into logs right now in the cloud in our whole, I don't know whether it's Kafkaized yet, but that whole messaging system is throwing information to the logs about the use of the API, but a user might want to do that as well.
Yeah, and tasks do that from the beginning. Every task has its own master log file. And it's not directly writable by the user, but just the idea of associating a log file with each object or something makes sense.
Right. Well, I mean, so maybe what we want to do is maybe we need to define what the standard, where you say write logging data, just write logging data, open, close.
Mm-hmm.
What does that write out? Okay. And, and maybe it's something quite simple, but, I mean, there's so many things it could write out, dollar command line. It could write out, what was the evaluation environment? What was this? What was that? It doesn't want to write out too much stuff.
Yeah.
I think it wants to
But
write
like
out.
CPU and memory statistics.
Sure.
Things like that.
Yep. But I mean, I think if we design that, then, I mean, as I say, what I want to see is for people doing serious stuff, just, in the event of disaster, go back and look at the log file and have some idea what happened. So how can we move forward on this? And I mean, in terms of writing the log file out, presumably we can use the operating system's file system lock if it's just going to just a generic, well, actually, this isn't so obvious to me, but explain how this would work both on the desktop and the cloud. So you would acquire, basically, you've got assume you have multiple Wolfram engines running, right?
Mm-hmm.
And they're trying to write into a file. Is it or is it not the case that when you do an fopen in the operating system, what does that do if another process is opening the same file?
Yeah, I'm hazy on what it does in different systems, and also different file systems will behave differently. I know that NFS file systems, you're potentially going to corrupt things if you open it to append. There may be some
so we need a lock mechanism
guarantees
to make this work.
It would be good, yeah.
Or alternatively, we piggyback on the syslogd mechanism of the operating system.
So, but your main point is that by default they all go to the same file. It's not separated by process ID or something.
That's what I would think. Yeah, I mean, it's like something went wrong. Let me look at my, Wolfram engine, Wolfram log file. And, it's the same thing that I see. I don't know, like on my computer, right? There's a centralized log file, which I occasionally look at, that just contains all kinds of crud about all kinds of random device drivers that were timing out and all kinds of things like that. Right? And usually I don't ever look at that file, but when something goes horribly wrong, I do. And I think it's useful to have it be centralized, because otherwise you're like, oh, where can I find this particular file? Did I lose you?
No.
Okay. I mean, and then, we can have something where you say write logging data and then give, a file destination or a persistence. I think what we want to do is a persistence location of some kind. So you can say write logging data to the cloud, write logging data to my local machine, and then a default name for where you write it. And if you don't want the default, you put it, if it's a special log for some particular, I mean, I might choose to write the great results of my computer experiment into a log file because it's a convenient mechanism. I mean, I have a bad feeling that we may find that this mechanism is a more useful thing in some ways than the data drop for some purposes. I mean, data drop produces an immediately computable output that's immediately usable. This is producing a pretty dead output that will have to be scraped in order to be useful.
Right. Well, it would be nice to have either a dollar variable or some options so that if you call a function, the function may decide I'm going to log to a different place. I need to reset these things,
Great.
but then restore it at the end. So
Oh,
I don't know if that's
what you're saying. A dollar default logging location or something.
Yeah, right.
Is the default value for that in WriteLoggingData, but you can reset that in some way.
Yeah.
No, that makes sense. But I mean, okay, but so the real challenge is you're writing to a file. I mean, look, this might be a more general function in the end, which just says write to a file safely, even though there may be multiple processes trying to write to this file.
Mm-hmm.
How do you do that in general? In the
you'd have to get
a log file.
You'd have to get it. Well, you'd have to get a something like a mutex from the OS. Whatever makes sense on the different operating systems. And I was going to say that that the kernel has a generalized interface to a mutex in critical sections and different things like that this would want to take advantage of.
Okay, but I mean, or is there a more simple-minded way of just writing out a lock file? I don't know. I mean, I know back in the day, lots of programs used to use that kind of mechanism. Although it would fail from time to time, you'd have to go and remove the lock file manually, which is very painful.
Mm-hmm. I think in most systems there's a very fast lock that will guarantee you that it's probably the right thing to do.
Okay, fine.
I haven't looked at these details in a while in the kernel, but
well, look, this is I think let's try and iterate to get some design of what we think it will be useful, and this is a question to ask. Perhaps tech support, perhaps some other people who would be consumers of these log files. What will we try to log with? I think a budget of 200 characters per line. Okay, maybe I'm wrong about that limit. Maybe it should be less than that, maybe more than that. But that's the order of magnitude limit for how much we should log.
Yeah, I don't even know if you need to put much of a limit.
Well, but my whole point is, I don't want to see in these log files that we're logging the whole, kitchen sink, and that because there are other issues that.
You mean the default behavior?
Yeah, I mean the default behavior.
Oh, sure, yeah.
No, we don't have to limit it for a user wants to write a long thing out. That's fine.
Yeah, got it.
And the user wants to write binary data out. That's fine, but that's not going to be the default.
Yeah. The
default is ASCII, comparatively short. I think Bob here is mentioning a queue system. I don't know what. I mean, yes, to queue up the output, to queue up the things that have to go into the log files. Yes, I mean you don't want to lose it, just like we're doing for the data drop now. The data drop is I hope been fully set up so that things queue and do not get lost, right?
Well, that development is queued up.
Okay. Queuing is queued. Okay,
Yep.
Well, fine. All right, let's go on to the next topic. I think we're done with this one. If that's
sorry, I think I have a question. I was thinking about this login idea, and I was thinking of these situations in which users or you send an email saying, "Why was this geographic so slow?" And I was wondering, is there any way of actually having some login of some functions that then we can explore a posteriori to see what happened?
Well, I mean, in that particular case, it was going to the server, right?
Yes, but from the point of view of the client. So I was thinking perhaps there is a way of making the function write something. It might be in memory, something that can be explored after the fact. After the function has evaluated, the function may have been writing something to somewhere in memory or a file where we can look at.
Well, right. I mean, that's essentially in operating systems, and God, I'm so out of date with these things. There used to be these, what is it called? trace, what the heck is it called? It's some way of running an operating system so that you can, not an operating system, a CPU, so that you're tracing every operation. What is that called? Ptrace? I don't remember what it's called. Anybody know? Joel, do you know?
Well, strace can show you system calls, if
Okay,
that's what you're thinking of.
That's the thing I'm thinking of. Yes, yes. But and what is that again?
It's just showing you system calls that the program is making. So even if you don't have the source, you can see, oh, it did an fopen on this path or something.
But that's a mode of running the executable so that you are tracing system calls.
Yeah.
Is that right?
More or less.
But I mean, I think that because I think what Jose is asking, I mean, I don't think it's realistic to be storing all this data, all the time. I think the only, you could run it again with this kind of trace mode enabled. That seems like the realistic thing to do.
Right. So, I mean, there is a way of activating, say, debugging information in, say, geographics. But of course, this can be done. I mean, it may, I don't know how to say. So it would be good to be able to activate it a posteriori.
Right.
So it wasn't shown, but if something happened, it would be nice to see it a posteriori.
Well,
perhaps the next time it doesn't.
Right. But so I would make a different suggestion, which is, which relates to my messages that are off by default thing. But there's one bizarre possibility would be in some things like geographics where you have to call a server and so on, there could be something where if that is called within a, I don't know, let's imagine it's called a logging block. Not probably the right name, but something like this. If it's called within a logging block, then all those functions which have the ability to generate log files will do so. So, for example, in the case where, in the case of these things that have to go to a server to get data, like entity lookups, like all these kinds of things, inside a logging block, they would be writing that. The fact that they are doing that to the log file. Normally they wouldn't, but if you said logging block of that, then they would do that, let's say.
I see.
I mean, in other words, the main issue is right now, look, many systems have the notion, set debug on, whatever that means. It's usually very undefined. And it's usually very capricious on the part of one programmer did something, another didn't, and so on. But I mean, the suggestion here would be to try and somewhat, to particularly to log all network calls, because those are things that could get slow or could have problems or could, whatever. And then we could go on and start logging other kinds of things. And the notion would be, rather than generating these things as, well, okay, so the immediate thing people are going to want, if we give them logging block, which logs to an external file, is they're going to say, I want to see that stuff in my notebook interactively. And that then goes down a slippery slope of essentially messages off by default. But this is a different mechanism, perhaps, for doing that type of thing.
Right. I was thinking perhaps of having a dollar variable that you can consult after the evaluation to see whether something, it's a bit like the stack trace of when there are messages. That's very useful too.
It is very useful, yes.
To detect what happened.
Isn't it the case, this is so pathetic that I don't even know this, that do we still store the time of every output line? I think I'm losing my mind, because I remember in SMP, which means 40 years ago, that there used to be a #I for the input, #O for the output, and #T for the time for each output line. Do we have that? I've forgotten. I'm horrified to say I don't remember whether that's something that we've ever implemented.
I think the cells store the time, not the timing, but the time, the absolute time of evaluation.
No, they do store that, because you can see that in the notebook history.
Right.
But we never did that. Okay, well, that was one of those features that that I guess I thought wasn't important, and the fact that I don't remember, I mean, okay, but I mean, that's the most minimal thing. What you're saying is that, are you suggesting something? See, because that's, what you'll end up with is, uh, out logs or something of 17 is what were the things that were, because you definitely don't want to do something where, where it's just a single dollar variable and it's overwritten the next time you have an output line. That's just a formula for people to be super frustrated. Oh my gosh, I got this amazing, this amazing error case. Oh shoot, I just, overwrote it. I don't think that's a desirable situation. But the idea of a, out logging or something of 17, putting something in there. So that's an interesting idea that this could work with. So the idea would be that this logging block thing, in addition to writing to an external log file or instead of or something, could also write to essentially an internal log, which is something that is associated with these output lines.
Right. To compare, for example, with a previous evaluation.
Yeah. Well, it's an interesting idea to have. What this is effectively is, I mean, this is, wait a minute, don't we have a mechanism? I'm so embarrassed I don't know this. Yes, message list. I'm not as crazy as I thought I was. Look, that gives you, and the fact that nobody here even knows this, that's the list of messages. So if I go here and I say message list / range minus range of 50 or something. Okay, that's kind of cool. Did you even know you could do that?
No,
I never tried that before. So that's telling me for the last, okay, I'm now curious if I do this over, I'm at line 926. I'm going to go to range. This is going to show me for my whole range 926. And let's say, let's delete cases just to avoid total craziness. Delete cases of null list. Okay. So this shows me that's in this session, that is the complete list of error messages that I encountered in this session. It's kind of interesting.
Interesting. Yeah.
I never looked at this before. So this is so for example here, I'm now really curious. I can say counts of that. And oh, I see, I don't want to do that. I want to say counts of flatten. Okay. Okay. General stop. Vertex list argt. Yeah, Jonas is pointing out you can replay the input. The fact is you can replay the input. That's why it says 930 : equals. If you simply type in of 930, you'll re-execute line 930. But if I type in of 930, it'll just re-execute it. So, okay, so what this, look, this is in the category of something which I think is a general thing we should be thinking about, which is, again, my messages off by default, things that aren't definitively wrong but are kind of iffy, that we know happened. And the question is, the difficulty is, how do we do that consistently? How do we, across 6,000 functions, how do we consistently put in messages? Well, the answer is we're not going to be able to do that. So what will have to happen is, over time, we'll just gradually add messages, and it'll all be a bit of a mess, just as log files are a bit of a mess. But if the log file happens to contain what you want, you're a happy person. But I think this is in the category of, we can start off by, I think this notion of a message rather than what can I say, a log message rather than an error message is a useful way to think about this. And so what we're suggesting here then is that for every output line, just like we accumulate message list, we could say, logging list or something of whatever, and then this would be okay, so then what would happen is we could have something that's a logging block, which is like a soripta or like a timing type thing, where it brings back in, or it could even be called logging of expa or something, which would then bring back not just the result of expa, but also just like timing does, the the log list, so to speak. And that would be, well, there could be things that are written to the log file by default. Look, I think this is in the general category of, okay, there's different mechanisms here. One is a standardized log, which is very much at a system level. Another is much more application level. Right, Kobe is commenting that if we had logging information, we would be able to have more accurate error messages. Yeah, I don't know if that's true. I mean, but just being able to give more context for the message is always useful. And I agree that our, that mechanism that we added only a few years ago for dealing with, where we can say, where we do something like this. That's not a good example, is it? What do I want to do? How do I want to get how do I get a good message here? How do I get something which is generating a message? Oh, I don't know. Let's say, okay, there we go. Now, the fact that we can go into that message and say show stack trace, that's really useful. Might be even more useful in this case if it said that x equals 10 in the case where it's failing. But even this is already useful.
Yep.
Okay, let me show you an idea that I had about trace yesterday that actually Max already implemented something. So trace, a famously unused function. Okay, let's see if I can demo already.
I use trace print quite a lot.
Yeah.
Okay. What's that?
Sorry, I said that I also use trace print quite a lot.
Okay. Well, this is, what is this? This was an attempt to make something I just thought of yesterday. Let's see whether it does what Max said it would do. This is just code that he just sent me. Let me just type the example that he gave here, or roughly. I don't know what module scope is doing. But what this is doing is this is showing the evaluation history of that expression. Right. So, I mean, this may be still too obscure, but the idea is this is showing, it's like causal graphs in our physics project. Okay, that's needless to say, that's where it came from. It's like, where did this result come from? Right. So there's something here which is saying, I don't understand what the heck's going on here. What on earth is going on? Oh, I see. Why is that 16 not contributing down to the 18? I'm confused by that. I think there are arrows going the wrong way here.
I don't understand this, but a trace view, something that can visualize the trace, because the problem with trace is that it's usually so large that it's difficult to navigate.
Well, I agree. So the question is, can we make a graph? When we invented trace in 1990, we did not have the notion of graphs.
Well, more than a graph, it's something that has openers so that you can decide which path.
Well, yes. Right. I mean, that's a different thing. Is a trace print that prints into a notebook, which has openers.
Right.
That's something we should try to do. I mean, I haven't used trace print in so long. Let's see what this does in that case. But the problem with trace print, yeah, the problem is I've just been in my obsession with combinators. I've just been studying this. The difference between reevaluation recursion and expression traversal recursion. See what I'm saying?
Mhm.
And those two things are not distinguished in traceprint properly. In other words, if I do something where I say, I don't know, 3, 5 times 6, 7, 5 plus 8, etc., and I say traceprint that, there are two kinds of recursion that are going on there. Actually, let me go here. 6 times 5, 6 plus 8. Oh, and even more, well, I could probably have a better example here, but the difficulty is that I'm not distinguishing here between walking through the list and going into one of these. Actually, the worst case is F goes to G, goes to H, goes to I, whatever, a succession of things in evaluation. So, for example, if I were to say X equals Y equals 7, or so X equals 7, Y equals X plus 8, etc. Now let me go trace print of list 4 plus 5, 4 plus X, 4 plus Y. Okay, so part of that evaluation chain is the X turning into 7.
Right. So I think because you are losing the nesting of trace here, it's difficult to follow.
Yes.
So I think trace print is more useful with a second argument in which you specify which actual expressions you are interested in. And that's very useful even in huge expressions.
Fair enough.
Yeah, that's how I'm using it.
For example, I've placed in the chat a link to a mathematical stacks change post with some ideas for trace views.
Okay. Which has some implementation of this stuff.
Right.
Yeah, there's some nice things here. Yeah, I mean, something like this is probably, I mean, look, this is, again, in expression browsing. This is the trace view is a particular example, I think, of expression browsing.
Exactly. Yeah. This type of thing at the end with openers that you can select you can sequentially select the part you're interested in. That's pretty useful.
Yes, I agree. I mean, I think that you know, I mean, that's the question of expression browse, which we've also talked about at length, and we really should get to do at some point. But I mean, that's also related to the too big business and whether you should be able to click on, when you get a too big output, should you be able to just click on, something like this? Should you be able to click on that rather than doing this global show more?
Right, exactly.
Look, I think we should add to, I don't know whether we have this on the global project list, the expression browsing thing. It's something we should look at, and we should probably have a couple of design meetings and see if whether we can finally nail this one. And as part of that, we should talk about trace print. People in the live stream are talking about the debugger and the life and times of the debugger. Unfortunately, it just didn't work very well. It just hasn't been a big, I don't know why are there 2 copies of this? Oh, because I have 2 different kernels running here and it made 2 copies. Okay, 2 questions. Who uses the debugger and why has the debugger been as comparatively unsuccessful as it has? I mean, clearly one major reason is because a step-by-step debugger is good if you're doing a procedural language. I mean, in fact, I was just writing about this in my story about combinators. The big idea of functional programming is you don't have to be picking out the program counter. In a procedural language where you go from here to there to there to there to there to there to there, then you are essentially walking through, program counter space, and you always know there is a current state. And so the notion of stepping in a debugger makes perfect sense. When you have a functional programming, you are essentially, you're eliding and collecting a lot of that control flow, and it's much less obvious how the stepping action of a debugger should work. In the case where, for example, you can have sort of, where you're doing an operation that's listable and you're going across a whole bunch of elements and so on, what does the debugger do? Does the debugger is the debugger essentially tracing the operation of the evaluator, or what is it doing? Clearly, the fact that traceprint can do something indicates the debugger can do something as well. But the notion of step over and so on, I think, is much less clear in a functional situation than it is in procedural, code. But does anybody want to comment on the state of the debugger? Who uses the debugger here? I haven't used it in years now.
I don't use it, no. But
Why not?
I use trace and trace print, etc. Yeah. For example, something I do very, very frequently is that when there is a message and I don't know where it's coming from, I compute the whole trace, then I search for the message. I go directly to the previous expression, and I know where it has been generated.
Why can't you do that from the stack trace?
Because sometimes the stack trace doesn't show all the steps, right? If it gets too internal, it will stop.
Yeah, okay, fair enough. But there's another reason, which is the stack trace is where you are nested in, again, it's this issue between expression traversal versus reevaluation recursion.
Right. And sometimes you want to know the previous expressions, not the actual one that generated things, because you want to know what happened before.
Yeah. Well, okay. So the question, Sandra is commenting that he still can't figure. He doesn't know what's wrong with the debugger. Yes, I think we all have this experience that the debugger was unusable, but we just don't quite know why. Anybody else want to comment on that here? Jose, why do you not use the debugger?
I have tried a few times, and I think I just get confused because I don't use the debugger much either in C. So I just don't have the mindset of using the debugger in general. Well, with trace, I have access to the whole expression at the same time, and I like this.
Well, I know, but I mean, this notion of being able to do computable things. Look, the whole idea of trace. This was a long-running story of mine to try to represent the essentially, space-time history of a computation. Okay, that was the idea of trace, that you could pick up the whole computation and compute things about the temporal sequence of a computation. Unfortunately, well, it wasn't as usable as I had hoped. Now, maybe using graphs and things, we could make it much more usable. Or possibly using this, really the combination is probably the most powerful thing. The combination of both graphs, because in your advent calendar windows type idea where you're opening things up and seeing what's inside, that's still, in the most obvious way of implementing that, that's still going to be quite linear. And maybe the thing that we ultimately want is what we're working towards with graphs, which is the ability, as you have in things like System Modeler, given a graph, you can double click a node, which is at first a summary node, and then you can open it up and see what's underneath that. So Ethan is commenting that debugger in Python is essential, but we just don't know. Comments about debuggers here. Okay.
So Danny, I know Danny uses the debugger in C quite a lot, but do you use it in top level, Danny?
No, I do not. I think I used it years ago when I worked on Alpha and the Workbench. I use the Workbench debugger, but I don't think I've ever used the built-in one.
What is the Workbench debugger? Various people are saying that that's a nicer thing, but what is it? Is this going to crash my session to show all for this trace of plot? Okay, Ethan is saying nobody thinks in terms of graphs. Maybe you're right. I mean, one of the mysteries of combinators is why the idea of unnamed variables has never caught on. And it is true that you can deal with that in a graph-based way, and it's really, really hard to understand. Boy, my poor machine. Don't crash my session. I hope you're not going to crash my session here, because this session had a bunch of useful things in it, as the fact that we're on line 947 might suggest.
I use debuggers in both for a lot of Java and things like that, and I do try to program in a functional style, even when I'm doing imperative stuff. And you run into the same thing in the debugger. If you have a heavily nested expression, steps into more than you care to most of the time. And the Java debuggers will have ways to say, exclude this, native library. I don't want to step into the Java implementation of strings and things like that. So there's a UX to exclude things from being step-inable. And once you have that filter, then this is getting back to why I use trace print with the second argument. I can specify, only show me things that are calls to these functions that are of interest. So it seems like that's going to be part of it, is just specifying what you're interested in stopping at.
This output is, look, what happened here is a lot of things that would usually just be pointers in memory just got disgorged into a giant structure here, which is incredibly non-useful. I agree. I'm still not giving up on the idea of using graphs in some way to represent the flow of information. I literally have just understood, like with combinators, my favorite topic of the week, causal graphs finally show me what the heck is going on, which I just could not figure out at all from looking at the actual expressions and so on. And this isn't an adequate causal graph, so this is not doing the right thing here, but it's still, this is inadequate. This is clearly not useful here. Look, I do think we should, clearly this comes up every so often, this, what are we going to do with the debugger? What should we, let me just comment, and this wasn't what the direction of this meeting, the code assistance project is the best way, prevention is better than diagnosis and treatment, so to speak. The best way to avoid, once you're in a debugger, you're already, sort of behind, so to speak. The best thing is write correct code in the first place. And that's why there's a big emphasis on code assistance. And the question is, can a lot of the things which land one up in the debugger? I mean, the fact is, look, I write tons of code, and occasionally, the number of times when I'm like looking at it and scratching my head and really confused is not all that large. Well, I had one on a live stream actually a couple of days ago, which I still don't know the answer to, which was a deeply, which actually would have been a good example as a very, very bizarre thing of something capturing some variable somehow in some, piece of code, and actually it's a bad sign. I didn't even think of using trace and so on to debug that. Probably didn't help that it had module variables in it. And as soon as you have module variables, you again, the idea, because you don't know what the name of the variable is going to be, you have another can of worms there. But look, I think code assistance prevention of bugs is the best first step. then the next question is, then things like the stack trace business is good to, the sort of situational awareness of what caused the bug. And then the next question is it useful to be able to interactively step? Is it more useful to be able to have a data structure that you can then analyze? Where is the real utility? The reason to have a stepping type thing is, for example, one of the principles of debugging is, do you expect that you're going to be able to rerun the code and get the same bug to occur? If you're trying to debug when you do not have that kind of reproducibility, you've got a different problem on your hands. And that's where all this logging stuff is relevant and so on. But assuming it's reproducible, I mean, back in the day, one always used to worry about, I'll put a breakpoint in this piece of C code or something because I don't want to, you didn't have the assumption I can just run it again and, with some different instrumentation. Anyway, I think this requires a custom meeting, which this is not. So I think we should move on here to the next item, which unfortunately is not completely unrelated. Oh boy. It's really SMP Redux time. This is a, controlled release hold. The enthusiasm is palpable.
So is this related to your discussion yesterday of the different ways of traversing for evaluation?
Somewhat, yes. You know what? We're not ready for this. This is a discussion to be had once we understand traversal orders and other things. I mean, there's very subtle issues. These are all together. All these things about the causal graphs of evaluation, the traversal orders, the recursion, sequence, et cetera, et cetera, et cetera. They're all a related set of things. Mm-hmm. They're all rather interesting and rather deep kind of issues.
Yeah, but probably these two. So, yeah, you sent an email about this, but
yeah, well, that's the same thing. That's related to all these things. They're all connected.
Yeah. Okay.
So is this actually. That's a piece of mixture of history and obscurity that I think we should. Let's see. This is okay. There's a function repository item for expression viewer. Oh yeah.
Interesting.
Right. Yeah, this is exactly the kind of thing that, this expression browse thing, it's exactly the kind of thing I was thinking about. The thing is, what's needed is a bunch of heuristics that don't land you up with this type of stuff.
Mm-hmm.
Because that's just annoying.
Yeah.
And it's like a thing that what was I going to say? Yeah, it's like common sub-expressions, right? We've at different times, and I don't know whether there are things in the function repository for doing this. It's like, you solve a cubic equation. It's a big mess. You say, I would prefer to define some intermediate variables. Okay, question is which intermediate variables? Because if you define it all the way with intermediate variables and you have kind of a DAG representation, it's absolutely incomprehensible as well, right? So what lumps do you define as your sort of intermediate variables? What lumps do you define as the thing that is a browser element as opposed to just giving it literally? I mean, like this rule, this is just wrong. It shouldn't be like that. It should just be 1 arrow 2, perhaps. It's, what elides. Now, back the original short code, which hopefully has been rewritten long, I mean, I wrote that original code for doing shortening of expressions on output, which uses a bunch of heuristics. Like it always has 2/3, 1/3. If you give a long list, it'll show you the first 2/3, then an elision, then the last 1/3 type thing, which I think is useful. But there's a whole collection of heuristics about what level of granularity to use here, and maybe there's a way to parameterize it. I'm not sure. Okay. let's go on here. Okay, position largest. Okay, I seem to need this function ridiculously often. What I'm doing is I'm trying to find the position of max in a, I mean, so really, I mean, is it the case that what I'm really asking for is position by?
Yeah. You also might want to ask yourself why Max is hiding from you in the first place, but I guess that's another discussion.
What?
You said you wanted the position of Max. What can I say?
Oh, I see. Not quick enough. I mean, position by would do it.
Yeah, well, the thing is,
no,
it
actually,
generalizes better so that we don't have the situation like the take largest family, where we have multiple maintenance, lots of documentation, knitting, and et cetera, et cetera.
I find take largest very useful.
I agree with that. I just think that we have this proliferation of 4 functions where maybe we needed that. I don't know, but in this case, I don't think we do.
Yeah, well, okay, fine. But I mean, so the issue is I'm trying to find the position of, let's just understand the definition of this. You know, what on earth? I'm not, I've never used position index. I know we have that. What does it do?
Yeah, it's saying 4 is found at position 1, 5 is found at positions 2 and 6. So we have discussed the idea of position largest several times in the past, and we always got stuck in 2 things. One is whether to return a list of numbers or a list of lists, because we have to respect the name position. And the other one was the fact that sometimes or frequently we wanted both what is the max and where it is. And that's why we came up with the idea of combining both things in take largest. But
well, what about position index having a second argument?
To do what?
That's a filter that basically says I only want the position index of the max in this list. I mean, this return would look very much like the return, which I don't like very much, of, constrain min or something, where I'm getting both the value and people are asking here, that would be an amusing thing to put in. I mean, to put SMP into external evaluate. Boy, that's a weird idea. I had not thought of that idea. Thank you guys for that idea. That is a deeply weird idea. I mean, we could do it. I think I'm not sure I would recommend it necessarily. I think I would like to think that all the good ideas from SMP were captured in Wolfram language. Oh my gosh, reboot failed? How could my reboot have failed? Help! I'm rebooting a virtual machine that thinks it's 1986 right now. Well, I don't know. Whoa. Let's try one more time and then I give up. But that is a very amusing idea to put this into external value. It's a good internish project at some point to try and make that work. There we go. Well, I don't recommend. I mean, I'm. Oh dear. Okay. Yeah, Matrix an Easter egg, Ethan says. Yeah, I agree. It's an amusing thing. It's I mean, the C code is runnable, I think. I mean, it's obviously running here, although, you know what, it's running inside a virtual machine that thinks it's 1986, which may be necessary to get all the system calls to work and so on. Anyway, okay, let's go back to position. Okay, write all the time. Sandra is saying he writes all the time, ordering hash comma -1 ampersand. What does that even do? I hate to be confused here, but
I think this will be mapping over a list of lists. So ordering -1 gives you the largest. The position of the largest.
The position of the largest, right. Right. Okay, that's what okay. Yes, okay. So, I see. So that's exactly what we're talking about here.
Right. Well, there is a problem of what happens if there are 2 times 10 in that list. So the natural thing to return is a list of.
Well, is that what this is doing? This is not what this is doing, right? Because this.
No, it's just giving you 1. But if, for example, say -2, ordering -2.
Yeah, then it will give 2 of those.
Right.
Right.
So we have a few ways of doing this, but it's true that they are obscure enough that it's not easy to think of them.
Right. I mean, for example, I haven't used this. I'm sure I knew it at one time, this ordering -1 thing. Okay, and what is the other way of doing it?
So the preferred way, or the way I use right now, is take largest, because usually I want both the element and the index at the same time. That's very useful.
Okay, I should be using that. I haven't been using that. Right, so you're saying that if I say the position of the maximum I can get by saying, let's say I say, and then I say take largest that arrow index, comma 1.
Right.
Well, can I just do that?
No, you have to specify a number. Reevaluate again.
Okay, but there are in fact 2 of them.
Right. So this function doesn't know that. You have to specify the right.
Right, but then if I say here,
yes, and you can also say all. Arrow all will give you associations with all the information it has.
That's nice. I mean, I'm not using this, but it's nice.
Mm-hmm. And with the by function, it's now also able to give you both the value before and after the application of the function.
That was a suggestion, external suggestion by Sander, I should mention.
Why didn't that work?
You in 12.2?
Yeah. Did I get this the wrong way around? Yes, I did. So value is the value of the bide thing.
Right.
Yes.
Well, that's nice.
Mm-hmm.
You know, I have to say that something like position max is kind of one of these functions that one just imagines should exist. And it would help if the documentation search would take one immediately to something like this. Well, I mean, you're making a reasonable case that we have a way to do this that isn't that bad. And also that has flexibility for all these different cases. Like what happens if there is I mean, there's always going to be at least one largest, but there might be a tie.
Well, that's why I brought up the issue of, using ordering versus take largest, because they behave differently in that setting.
Right. Well, ordering has a secondary ordering. I don't know what take largest. What is take largest secondary sort?
Oh, it's not the sorting. I mean, there is such a sort, and I don't remember if it's first come, first seen or what, but or just the default sort. But ordering whatever -1 will just give you one position, whereas take largest with goes to index will give you all positions of the largest element if there's more than one.
No, but I think that in that sense they behave similarly, because you have to specify the number of elements you want. These functions
Not to
do
take
find-
largest.
Sorry?
Well, if you say take largest, give me the largest element, it's going to give you all of them.
No. Take largest, you have to say, give me the 3 largest. And then if 2 happen to be equal, that's fine. But I think that's ordering.
Okay,
Yeah, you
I'm
always have to give it the
misremembering.
number. Yeah, you always have to give it the number of elements you want.
Okay, I was misremembering.
Like
Which means you don't preemptively just get to say a tie, however big the tie is.
Right.
Yeah.
So the Wolfram function repo function does that.
Position largest.
Yes. No, sorry. Try with only one argument. And if it is repeated, oh, it will give you only one. Yeah. So it doesn't do it either. So so yeah, so that's perhaps the missing piece here, being able to find how many times the largest appears.
Ethan is saying, not just maximum needs selection and pattern. Lots of times you want the position and value of the top n based on some criterion, sorted in some way.
I think that's position largest by. You specify the criterion with the by function.
Yes. But, or position by. I don't think it has to be largest by, position by.
Well, with take largest by with the extension of the rule, you can get the index.
So what are you suggesting here?
I'm saying that with take largest by list rule index, we can also generalize this to a criterion.
Oh, with take largest by.
Exact, take largest by. With the arrow notation, and then the by function and the number.
Yeah, I mean, I understand that this will work.
Right.
This is the position max thing.
But max is the default. How should I say? So the function there is the thing to be applied. For example, imagine you say ABS. Take largest by ABS, and then you have a list of with positives and negative numbers.
Yep.
Right.
Yes, max is right. You're sorting numerically eventually.
Exactly.
Well, so what's your point? I mean, your point is that take largest with just list arrow index will give you the n largest things will give you the positions of the n largest things.
So I think this list goes to index is effectively positioned by.
Yeah, I know. I'm just not that keen on having. Yes, I agree with you.
It's just difficult to think of this name when you are thinking of position by.
Right. This needs more thought. All right, I think we should wrap up. We're out of time here. We're going to get to these.
So in a previous meeting, we looked at this first group, and we sent already some of these functions to developers, etc. So now there is a second group of functions we could look at, and
Okay.
I've separated them in subgroups.
Okay. All right. Well, that would be a good thing to do. I mean, we've got some. By the way, I don't know which group we should be dealing with this in, but we have got to generalize map and particularly parallel map to show progress. It's driving me crazy. Every time I use parallel map, I end up using parallel map monitored function repository entry. Because by the time I'm using parallel map, I know it's a big crunchy computation. There's no reason I'd be using parallel map except for a big crunchy computation. And parallel map monitor does an excellent job of, telling me how fast things are going and so on. Now, it's not perfect, but it's still, I can tell you, having used it thousands of times now, that it does well enough to be extremely useful. So I want to make sure, and I don't know which group that is. I guess it's Roman who's dealing with the parallel functionality. I think at least for the parallel functions, let's just put in preemptive monitoring.
That sounds like a primetime LCC topic.
I guess, or maybe it's a ECE thing. I mean, basically, Roman, look, now that we have the progress framework, it should be pretty easy for Roman to hook this up. Could you at least ask him that and ask him to look at parallel map monitored and see whether he can see how to make that a system level thing?
Yeah, sure.
All right. Okay, well, we should wrap up here. There's a little. I mean, we've kicked the tires on some things, but we haven't come to big conclusions. I do think there's a lot more to be said about the whole debugging issue, and there's lots more issues here. But we're making progress. So thanks everybody. Thanks to folks on the live stream for your input and participation, and see you again soon.